now. Okay, let's revisit the, inserting into Kovarex exactly 40 elements, and it's achieved by, like limiting where your inputs go, and the algorithm is, this inserter sets a value of 41 because that's how many, uranium-235 the recipe produces, and because it's connected to the input of this, arithmetic combinator that counts, how many products have been moved, specifically this one. So because this inserter sends both its signal to here and here, that's why we need 41. And yeah, basically that's it. So let's build another one. Really simple. It fits into its own form factor. You can achieve it with one, and if you don't want the delay, it seems like the output, this inserter that sits on the output, it takes first this uranium-238, like because its stack size is limited to 1, it, like it's slow to restart the cycle, but you can fix it by using a stack filter. It will take the uranium directly, and then I'm not sure what will happen to the other things. You might need an additional arithmetic combinator like this one that minuses the other uranium, and here you would need to set to 43, I guess. But basically, yeah, set the recipe, set the combinators, and this is how it looks like, right? So you have input because you need to supply the additional 3 uranium. I call it the the green stuff, or green uranium, because the other one is glowy stuff, right? Yeah, so connect the outputs, and this is a really simple setup. I just filter out the good uranium here. It goes back into the cycle, feeds this cycle, whatever. Oh, why is it not working? Wait. Oh, right, it's not enabled. Yeah, because I started with 0, right? So I needed to build up the uraniums until I could turn on all the centrifuges. But basically, this one is... I don't even know if you want it to have a condition. It might mess with the inner stack, I'm not sure. But, well. So, basically, you wire everything up in your one color. Signal exists everywhere on the circuit network equally. They should be oppositely turned like this. So I guess we can start with this one. So inserter to inserter to inserter to output, back to input, and to input here. I think that's the chain with the minimum amount of clicks and thinking. And then just sanitize the input of this one, because you can't send anything else, here, because it will well, influence the output, because here when this output inserter moves 1 unit, we limit its stack size, right? So limit the stack size and set the condition U is 0, our virtual signal, and read contents in pulse mode, right? So here as well. Well, I need to set 41 because the other guy is wired differently. All of these are wired on the same network, so this inserter will, both set this value and minus it here. Oh, I'll use this. So U minus uranium, see, so this one will, that's why I need 41. And it should work now. I mean, set the logic for the output inserter, or you know, like this one works when this one doesn't, so when U is more. And also we read the contents because we, you know, because of this one. So when we move that one uranium, you know, maybe I can show you here how far is it to completion. This one will set the uranium to 41, right? And it automatically will, well, not automatically, but because of the wiring, it will, you know, go through this logic as well and immediately minus the U with its one, you know, both as it sets the U and as it, you know, receives the input, and it will subtract it. So U will be 40. And now this inserter can start working. So this one will, oh yeah, because this one, you know, is not a filter inserter, and it seems to, you know, first move from the output, you know, in the backwards direction. So it will move this item and then this item. So there's a little bit of input delay. Phone calls. Now we just need the 40 uranium to start the cycle, or maybe 80. Let's see if I can get 80. Got 80. Oh, okay. Now it can start. Put those back. So maybe should do the wiring quickly for this part as well. So let's see, inserter to inserter to inserter to output to input, and finally this way. It will be very fast. Maybe I'll slow down the video. But here it comes, the end of the recipe. Oh, actually, I have to make it faster. Oh, what? Where's the? Oh, oh, okay. Wait, what? Oh, whatever. So yeah, here comes the end of the recipe. Let's see. Oop. Wait. Why is it? Oh, I didn't set the conditions. Alright, so this one works. I limited the stack size to 2. Well, this one has the same condition as this, as the output. And these, you know, the same condition as, well, the reverse, you know, when U is more than 0. So let's see. 3, 2, 1, let's go. So the U, see? Oh, huh? Did I? No. Weird. What? Is it not sending? Wait, why is it pulsing? It works as intended, but what is the? What is that pulsing? It's hard to see. It appears for only a millisecond, but what? But it's not reacting to anything else. This inserter is moving, and this one is inserter is moving the wrong, or I mean, the item that we don't react to. U doesn't exist because we only check for U and the uranium-235. But this inserter first moves, you know, the uranium-238, and then it moves the one that we react to, but what is that blinking all about? Well, I mean, the algorithm works, at least. See? It consistently moves those two, and then the uranium, you know. But what is the blinking? What is it reacting to? Or maybe this, you know, this hovering just shows, you know, it captures the pulse of the uranium-238 as it exists, because everything exists as a signal, right? But since we don't capture it, so maybe that's responsible for the blinking. Well, whatever. That's the logic. I tried to think of ways, maybe, you know, like how to make this inserter count when it, you know, like when it moves the 40 of this and then 2 of this and then trigger this one, you know, or somewhere in the middle, like when it moves, you know, 2 of these, you know, and then you know, reverse the logic when the input, well, the second output, as it is in this algorithm, when it would wait, you know, like this one would work first and then this one would wait for the, or somewhere in the middle, but it would require, you know, like manipulating the stack size, and we don't know at any given time what inserter is there, so it just complicates the setup. But, you know, like eliminating this small delay where this inserter, you know, moves 3 items one by one, if you really are concerned by that small efficiency, then, well, you can use something else. But and again, this is an algorithm I reverse engineered. Nobody, you know, like straight up told me about this or whatever. I just joined their this was already years ago, so more than 7 years ago, I guess, or something. I reversed, you know, I saw the setup, I reverse engineered it, and they were using like that slow inserter here, you know, because it guaranteed, you know, it was also a very, you know, well, an old patch of the game, so to speak, when there weren't this option to limit the stack size and stuff. So they were using this inserter because it didn't originally have any stacks. It was always guaranteed to be 1, right? So yeah, and I thought about it, and I thought, you know, like in the new patch it's possible to avoid that limitation, but yeah, now it's limited by moving this item first and then the item we need. And maybe you can add additional logic, you know, to capture the signals and make it, you know, the system too complicated that it needs to be just to get rid of this small delay. But oh well. But there you go. So yeah, so, you know, like convenient way to sort out the belt. You know, we capture the thing. If you have a lot of well, not really. Doesn't matter. Yeah, but basically we request some uranium, you know, from the outside, and then we just feed it back on the belt, and then we just get rid of the good material, you know, like this, or whichever other way you prefer. And this condition was there just to not to clog up the belt. You know, I had it set up a little bit differently before, but that's the setup. Thanks for watching. Hope you learned something.